Your engine is speaking to you every single day, but most drivers never hear the warnings until it is too late. The difference between an engine that dies at 150,000 miles and one that powers through to 500,000 is not luck or brand loyalty. It is about understanding what actually destroys engines and knowing exactly how to prevent it. The truth about modern maintenance schedules is that they are designed by marketing departments, not mechanics. Those extended service intervals you see in your owner manual exist to make vehicles appear low maintenance during the sales process. Meanwhile, experienced technicians who rebuild engines every day will tell you something completely different about what your car actually needs to survive long term. Start with your oil change intervals. That recommendation in your manual suggesting you can go 10,000 miles between oil changes or wait an entire year is not based on what is best for your engine longevity. It is based on what looks attractive on a specification sheet. Real-world conditions demand fresh oil every 3,000 to 5,000 miles, particularly when you factor in stop-and-go traffic, short trips where the engine never fully warms up, extreme temperatures, or dusty environments. What happens inside your engine when you stretch those oil changes is not immediately visible, but the damage accumulates steadily. Oil breaks down, loses its viscosity, and stops protecting critical components. Sludge begins forming in passages, restricting flow to vital areas. The variable valve timing system starts suffering, timing chains stretch prematurely, and cam phasers begin their slow death march. 5 years down the road, you are looking at catastrophic failures that could have been prevented with more frequent oil changes. Selecting the right oil matters just as much as changing it regularly. Modern engines with tighter tolerances require synthetic oil to maintain proper protection, while older designs often perform better with conventional oil. Never compromise on filter quality either. That bargain filter might save you $5 today, but it will cost you thousands when contaminants slip through and score your cylinder walls. Always use manufacturer specification filters or reputable, aftermarket equivalents that meet or exceed original equipment standards. Your transmission fluid tells an even more deceptive story. Manufacturers love calling it lifetime fluid, but they never specify whose lifetime they are referencing. Certainly not your transmission's lifetime if you want it lasting beyond 150,000 miles. That fluid is constantly exposed to extreme heat, pressure, and friction. It collects microscopic metal particles from normal wear, breaks down chemically, and gradually loses its ability to protect precision components. The insidious part about transmission fluid degradation is how well it hides its condition. The fluid might still appear relatively clean, maintain its color, and smell normal, yet be completely saturated with friction material and metal debris. By the time you notice harsh shifts, slipping, or hesitation, internal damage has already occurred. Rebuilding a transmission costs anywhere from $3,000 to $5,000, all because of neglecting a $60 fluid change. The proper approach involves draining and refilling transmission fluid every 60,000 miles for conventional automatics, possibly extending to 90,000 for certain hybrid systems. Never perform a high-pressure flush on a transmission that has never been serviced, as this can dislodge accumulated debris and cause immediate failure. Drain what you can, refill with fresh fluid, and repeat the process if necessary. Always use the exact fluid specified by your manufacturer. Toyota requires their WS specification. Honda needs their specific ATF formulation, and mixing in universal fluid is asking for expensive problems. Engine coolant represents another fluid that deteriorates invisibly until catastrophic failure occurs. Fresh coolant maintains a carefully balanced chemistry that prevents corrosion, lubricates the water pump, and transfers heat efficiently. Over time, those protective additives deplete, and the coolant becomes acidic. This acidic coolant begins eating away at aluminum components, destroys rubber seals, erodes head gaskets, and creates electrolysis that pins holes in radiators and heater cores. The warning signs appear gradually at first. You might notice the overflow tank needs topping off occasionally, catch a whiff of sweet antifreeze smell, or see minor white residue near hose connections. These early indicators are your opportunity to act before major damage occurs. Once you see white smoke from the exhaust or find coolant mixing with oil, you are facing head gasket failure and potentially thousands in repairs. Proper coolant maintenance means complete system flushes every 3 to 5 years using only the type specified for your vehicle. Never mix coolant types or colors, as different formulations can react chemically and create gel-like substances that block passages. Red coolant systems require red coolant, green stays green, and those fancy extended life orange or yellow coolants have their own specific chemistry that should not be contaminated. Timing belts represent one of the most critical yet overlooked maintenance items that can instantly destroy an engine when they fail. Your owner manual might suggest replacement at 100,000 miles or 10 years, but rubber deteriorates from heat cycles and age regardless of mileage. Many timing belts develop cracks and lose tension well before reaching recommended replacement intervals, especially in engines with poor ventilation or oil seepage issues. The terrifying aspect of timing belt failure is its sudden, catastrophic nature. There are no warning squeals, no gradual degradation you can monitor, just instant failure that sends pistons crashing into valves. Interference engines suffer bent valves, damaged pistons, and sometimes cracked cylinder heads when timing belts break. Non-interference designs fare better, but still leave you stranded with significant repair costs. Intelligent owners have their timing belts inspected starting at 60,000 miles, looking for signs of cracking, glazing, or contamination. When replacement time comes, changing only the belt is false economy. The tensioner, idler, pulleys, and water pump should be replaced simultaneously, since labor represents the majority of the cost and these components wear together. Spending an extra $100 on parts during a timing belt service beats paying for the same labor twice when a tensioner fails 6 months later. Spark plugs might seem like simple components, but worn plugs create a cascade of expensive problems throughout your engine and emission system. Weak spark means incomplete combustion, which sends raw fuel into your exhaust system where it destroys catalytic converters worth thousands of dollars. Misfires cause uneven power delivery that stresses engine mounts, transmission components, and creates harmful vibrations throughout the drivetrain. Modern platinum and iridium plugs last longer than old copper designs, but they still require replacement well before their advertised lifespan. Turbo engines, direct injection systems, and vehicles running on lower quality fuel see accelerated plug degradation. Carbon buildup, oil contamination, and heat cycling all contribute to premature failure that manufacturers do not account for in their replacement schedules. Quality matters immensely when selecting replacement plugs. Premium manufacturers like NGK Denso Bosch and Motorcraft spend millions developing plugs optimized for specific engines. Their iridium and platinum designs maintain precise gaps longer, resist fouling better, and provide consistent performance throughout their service life. Generic plugs might cost half as much, but they will not last half as long or perform half as well. Fuel filters quietly protect your entire fuel system from contamination that would otherwise destroy expensive components. Modern fuel might seem clean, but it contains microscopic particles, water droplets, and chemical residues that accumulate in your filter. As the filter clogs, fuel pressure drops, forcing your fuel pump to work harder and run hotter. Eventually, debris bypasses the filter entirely or the pump fails from overwork. The symptoms develop gradually as the filter restricts flow. You might notice slight hesitation during acceleration, reduced power under load, or intermittent stuttering at highway speeds. By the time these symptoms become obvious, your fuel pump has already suffered premature wear and your injectors might be partially clogged with debris. Cleaning injectors costs hundreds while replacing a fuel pump can exceed $1,000 with labor. Preventive fuel filter replacement every 30,000 to 60,000 miles. Costs less than $50 and takes most mechanics under an hour. Cars driven in dusty conditions, those using questionable fuel sources, or vehicles that frequently run with low fuel levels need more frequent changes. Always use quality filters from established manufacturers, as cheap alternatives can disintegrate internally and send filter media throughout your fuel system. Brake fluid absorbs moisture from the atmosphere through microscopic pores in rubber hoses and seals. This hygroscopic property means your brake fluid is constantly degrading, even in vehicles that sit unused. Fresh brake fluid boils at temperatures exceeding 400 degrees Fahrenheit, but contaminated fluid can boil at less than 300 degrees. During aggressive braking or mountain descents, boiling fluid creates vapor pockets that compress when you press the pedal, resulting in complete brake failure. Testing brake fluid moisture content takes seconds with an inexpensive electronic tester available at any auto parts store. Simply dip the probe into your brake reservoir and read the moisture percentage. Anything over 3% indicates replacement is necessary. This simple test could prevent catastrophic brake failure that endangers your life and destroys your vehicle. Professional brake fluid flushes remove all old fluid from the system, including what is trapped in calipers, wheel cylinders, and ABS modules. This service typically costs less than $100 every 2 to 3 years, insignificant compared to the cost of accident repairs or premature brake component replacement caused by contaminated fluid. Always use the exact brake fluid type specified for your vehicle, whether DOT3, DOT4, or DOT5.1, as they have different boiling points and chemical properties. Differential and transfer case fluids endure extreme pressure and heat, while enabling your wheels to rotate at different speeds during turns. These heavy gear oils contain special additives that cling to gear surfaces, prevent metal-to-metal contact, and dissipate heat. Over time, these additives break down. The oil becomes contaminated with metal particles, and protection diminishes significantly. The warning signs of differential problems develop slowly, starting with subtle whining during deceleration or turns. As wear progresses, the noise becomes louder and more constant. Eventually, bearings fail, gears develop excessive play, and complete lockup occurs. Rebuilding a differential or transfer case costs thousands and often requires specialized knowledge that many shops lack. Changing gear oil is straightforward but messy work that many owners can perform themselves. After warming the vehicle with a short drive to thin the oil, remove the fill plug first to ensure you can refill before draining. The drain plug usually contains a magnet covered in metal shavings, which is normal in small amounts but concerning if excessive. Refill with the exact viscosity and type specified. Typically, 75W90 or 80W140 gear oil, with appropriate additives for limited slip differentials if equipped. The positive crankcase ventilation valve seems insignificant, but plays a crucial role in managing pressure and vapors inside your engine. When this simple valve fails, pressure builds inside the crankcase, forcing oil past seals and gaskets. Many engines burning excessive oil actually have perfectly good rings and valve seals, but suffer from a stuck PCV valve creating excessive crankcase pressure. Testing a PCV valve takes seconds and costs nothing. Remove it from the valve cover and shake it. You should hear a distinct rattle from the internal check valve. If it does not rattle or feels clogged with sludge, replacement is necessary. This $15 part takes 5 minutes to change and can eliminate oil consumption problems that would otherwise lead to engine replacement. Mass airflow sensors precisely measure incoming air so your engine computer can calculate the perfect fuel mixture when contaminated with oil residue from aftermarket filters or dirt from degraded air filters. These sensors provide inaccurate readings that cause poor performance, increased fuel consumption, and potential catalytic converter damage from running to rich or lean. Cleaning a mass airflow sensor requires special chemical spray designed specifically for this purpose. Never use carburetor cleaner, brake cleaner, or compressed air, as these can damage the delicate sensing elements. Remove the sensor carefully, spray the sensing wires without touching them, and allow complete drying before reinstalling. This 20-minute procedure can restore lost performance and fuel economy while preventing expensive diagnostic wild goose chases. Wheel alignment affects far more than tire wear, though premature tire replacement alone justifies regular alignment checks. Misaligned wheels create constant stress on suspension components, increase rolling resistance that hurts fuel economy, and make your vehicle unpredictable during emergency maneuvers. One pothole, curb strike, or worn suspension component can throw alignment out of specification instantly. Professional alignment requires sophisticated equipment and trained technicians who understand the relationship between caster, camber, and toe adjustments. While you cannot perform alignments at home, you can watch for warning signs like uneven tire wear patterns, steering wheel off-center when driving straight, or the vehicle pulling consistently to one side. Annual alignment checks cost less than a single tire and prevent thousands in premature wear across multiple components. Cold engine operation causes more wear than almost any other driving habit, yet most drivers unknowingly inflict this damage daily. When you start a cold engine and immediately rev it, oil has not reached critical components in the valve train and turbocharger. Metal surfaces contact directly without protective oil films, causing accelerated wear that accumulates over thousands of cold starts. The solution requires patience measured in seconds, not minutes. Start your engine and let oil pressure build for 30 to 60 seconds before driving. Then drive gently, keeping engine speeds below 3,000 RPM, until the temperature gauge begins rising. This allows oil to reach operating temperature and viscosity, while gradually warming engine components evenly. Turbocharged engines require extra care, as cold oil cannot properly lubricate spinning turbo bearings that rotate at speeds exceeding 100,000 RPM. Extended idling seems harmless but creates multiple problems that shorten engine life. At idle, oil pressure drops below optimal levels, providing marginal lubrication to critical components. The engine runs rich to maintain stable idle, washing oil from cylinder walls and diluting crankcase oil with fuel. Carbon deposits accumulate in combustion chambers and intake valves, especially on direct injection engines where fuel never cleans the valves. Modern engines warm up faster under light load than sitting stationary. After that brief initial warm-up period, driving gently brings everything to operating temperature efficiently, while maintaining proper oil pressure and avoiding carbon buildup. Remote starters provide convenience, but should not encourage extended idling periods that harm your engine while wasting fuel. Road salt and debris constantly attack your vehicle from below, creating corrosion that destroys brake lines, fuel lines, suspension components, and frame structures. This damage occurs invisibly until catastrophic failure leaves you stranded or causes accident-inducing component failure. Vehicles in northern climates or coastal areas face accelerated corrosion that can destroy a car in under a decade without proper maintenance. Monthly undercarriage washing during winter months removes corrosive salt before it penetrates protective coatings. Focus high-pressure water on frame rails, suspension components, and inside wheel wells where debris accumulates. Even vehicles in dry climates benefit from occasional undercarriage cleaning to remove accumulated dirt that holds moisture against metal surfaces. This simple maintenance prevents the heartbreak of scrapping a mechanically sound vehicle due to structural rust. Battery terminals develop corrosion that restricts current flow, forcing your alternator to work harder and potentially damaging sensitive electronic components. That blue-green fuzzy growth contains sulfuric acid that eats through cable terminals and battery posts. Modern vehicles with complex electronic systems suffer various malfunctions from poor battery connections that seem unrelated to the actual cause. Cleaning battery terminals requires only baking soda, water, and an old toothbrush. The baking soda neutralizes acid, while mechanical scrubbing removes corrosion. After cleaning and drying, coating terminals with dielectric grease or petroleum jelly prevents future corrosion. This 5-minute maintenance task ensures reliable starting, proper charging, and stable voltage for sensitive electronics. Your vehicle constantly communicates its condition through sounds that develop gradually enough that drivers often adapt rather than investigate. That slight squeal during braking warns of worn pads before metal-to-metal contact destroys rotors. The clicking during turns indicates CV joint wear before complete failure leaves you immobile. A subtle knock from the engine bay could indicate anything from bad gas to imminent bearing failure. Developing awareness of your vehicle's normal sounds requires occasionally driving without music or conversation. Open windows amplify external noises from suspension and drivetrain components. Any new or changing sound deserves investigation before minor issues become major repairs. The cost difference between replacing brake pads versus pads plus rotors plus calipers illustrates why early detection matters. Documentation might seem tedious, but maintaining detailed service records provides multiple benefits beyond just remembering when you last changed oil. Patterns emerge from documented maintenance that reveal developing issues before failure occurs. Warranty claims require proof of proper maintenance. Resale value increases significantly with documented history. Even your own faulty memory becomes irrelevant when everything is written down. Whether you prefer a simple notebook in the glove box, a spreadsheet on your computer, or smartphone apps designed for maintenance tracking, the method matters less than consistency. Record dates, mileage, parts used, costs, and any observations about vehicle condition. Include receipts when possible. This small effort pays dividends through prevented breakdowns, warranty protection, and increased resale value. The path to 500,000 miles requires no special mechanical knowledge or expensive tools. Just commitment to proper maintenance performed at appropriate intervals. Every fluid change, every filter replacement, and every small repair prevented larger problems that would otherwise cascade into expensive failures. Your engine does not care about the badge on the hood or the number on the price tag. It only cares about clean oil, fresh fluids, and components replaced before they fail. The difference between vehicles that die young and those that run seemingly forever comes down to owners who understand that maintenance schedules exist to prevent problems, not respond to them. By following these proven practices and listening to what your vehicle tells you through sounds, smells, and subtle changes in behavior, you join the select group of owners whose vehicles achieve extraordinary mileage, while maintaining reliability and performance that seems to defy age.